Hi everyone, good morning, good evening, good afternoon, depending on your time zone. My name is Alex and I will be your host for the next, 30 minutes, 45 minutes, maximum 1 hour on this short webinar related to Jenkins. In this webinar, basically what we want to discuss a little bit, it's about how we can detect vulnerabilities inside our container workloads using Jenkins pipelines. So what we are going to do here, we are going to create a simple application which is running inside a Docker container. And we are going to create different build steps inside the Jenkins job, which will download that specific code from a repo, from a Git repo. They will build the container. And after we build the container, we are going to do a security scanning for vulnerabilities using a third-party tool. In this case, will be Enter Engine. And if we find vulnerabilities, we are going to fail the build. If everything is fine, that build will be pushed to a Docker registry. In this case, here will be Docker Hub. But if you are here at this webinar, maybe you have some questions, right? Maybe you want to know more about Jenkins. What is Jenkins? What cannot give to us Jenkins? How does it fit in this ecosystem of DevOps? How it works? And of course, how we can insert security inside our Jenkins scripts and pipelines. And we'll see that using this practical example and demo. If you have questions, please don't be shy. Please type them in the chat. I'm not going to answer during the presentation, but I will try to answer at the end. So please type them in the chat. There is a question and answer section. Open new tickets here, and at the end we'll have 10-15 minutes to review them. So welcome, my name is Alex. I'm a training architect here for DevOps Artisan project. I'm a tech enthusiast and I enjoy playing with different technologies which are related to DevOps and DevSecOps. Don't forget DevOps Artisan, it's a training project and it's focused for people which are passionate about DevOps ecosystem. And they are trying to look for new opportunities in this DevOps world, or they want to learn more about DevOps. Don't forget, if you have any questions, please send us an email at askformore@devopsartisan.com. Again, remember the recording and the questions will be available to you after the webinar will be done. But until we are going to discuss a little bit about Jenkins and see the demo, let's see what is DevOps and let's discuss a little bit about the DevOps culture, right? So this term DevOps was created around 2007, 2009 by by a group of people, Patrick Debois, Gene Kim, and Joel Willis. And at the core, they are trying to represent the combination of development, dev teams, and operations, op teams. And from that point, it has given a rise to a movement that tries to bridge together the developer teams and the operations to be one team. And in this way, the purpose is to be able to deliver more added business value to the end users or to the customers and be more competitive, let's say, in the market. So DevOps, it's all about collaboration. Of course, at its core, the culture itself, it's basically a set of practices that are trying to reduce the barriers between the developers who want to innovate and deliver faster on the other hand, and the operations team who want to make sure that we have the production systems in a stable and a resilient way. And of course, the quality of that system does not change when the development team performs a new modification or something is changed. Don't forget that the DevOps culture is just an extension somehow of some agile process like Scrum and so on. And it wants to reduce the delivery times and give the ability for developers and the business teams to focus more on what is important, innovating and making sure that the production systems are not affected by any changes. The purpose, like I said in the beginning, is communication. And this communication is the link between dev team and the operations team. And this will create a better follow-up of an end-to-end production deployment. And of course, more frequent deployments, which will give us more quality and more resilience for our deployments. And of course, at the end of the day, it will save, I don't know, money for the company. But to implement this kind of DevOps culture, we have a few key elements in this process to be put in place. So in order to deploy frequently, we need some process called continuous integration, continuous delivery, and continuous deployment. So here we have these terms: continuous integration, continuous delivery, and continuous deployment. At the core of this process, of these concepts, we have the culture of collaboration, because DevOps, it's collaboration. We have some processes, right? We need to do some planning of functionalities. We need to do the development. We need to perform the continuous integration and continuous delivery. We have to do the continuous deployment to be in production up and ready as fast as we can and without no downtime. And besides that, we need also continuous monitoring, because if we don't monitor the entire end-to-end workflow, things can go wrong, systems can fail, and if we are not notified in time, we can lose, of course, our business, our customers, our users. And besides processes and culture, we have also tools, right? And tools, we have a lot of tools, a lot of choice of tools and products which can be used by teams in different scenarios. So the purpose is not to use all of the tools or specific tools. It's to use the tools that fit better inside your organization and can give you much faster delivery times, let's say. So of course, each team will have its own set of tools. Development will work with Git, with Jenkins, with Bitbucket, and so on and so forth. Operations maybe will work with Docker, with Kubernetes, with Terraform, and third-party tools. But as at the end of the day, it's all about how you use those tools and if those tools are making your life much easier. So remember, DevOps, it's all about collaboration, processes, and tools. And in this case, Jenkins, it's an example of one of these tools, right? So from the point of view of continuous integration, you can think that it's a software development practice where members of a team integrate their work frequently, right? And after each integration is done, this is verified using an automated build or test in order to detect different kind of integration problems, right? As quick as possible. This is the core. Continuous integration, or CI, it's an automatic process that allows you to check, I don't know, in completeness of an application code every time each member makes a change and pushes that change to an SCM, right? We can see that in a DevOps culture, continuous integration fits very well from the spirit of collaboration and communication, because the execution of this continuous integration will affect the entire members in the team, right? From the point of view of the work methodology, and of course, from the point of view of collaboration. Besides that, from the point of view of the implementation, we have to create some processes, right? We need to create, for example, to branch our code, to commit our code, to make pull requests, to perform code reviews, and so on and so forth. And these processes can be automated, right, with different kind of tools. You can think about Jenkins, Git, Azure, and so on and so forth, Google Cloud. And with those tools, we make the continuous integration alive. But continuous integration is just a short part. We have also continuous delivery. But as a high level, from a continuous integration flow, you have to think about of the following steps. We can have a pull, a code update. After the developer performs the code update on his repo, it will push the code to the SCM. Maybe in the SCM, you have some kind of scripts that are doing some unit tests and perform some code validation. And if everything passes, and this means that you don't have any failed tests, now you can merge your code changes. And after that, continue the flow in the pipeline. And the next step, if everything didn't break inside the code itself, is to create the packages, to create the binaries, and deploy those binaries somewhere else, right? But in order to do that, we have to use another concept, which is continuous delivery, right? So in the continuous delivery, we are taking the continuous integration and move to the next step, right? To deploy the application somehow in an automatic fashion in a staging environment or non-production environment or QA environment, right? And this workflow, it's called sometimes continuous delivery. It depends, because continuous delivery versus continuous deployment in some organization means the same thing. In some organizations are different processes. But here again, it depends on the culture of the organization. And what we are doing here, we are doing, again, we start with developing our code, our functionality for our application. We build the application, we test it, we deploy it, and we can perform a release on a non-production environment. And this continuous loop and continuous feedback mechanism creates the continuous delivery pipeline. So, looking at a continuous delivery workflow, here we have the continuous integration part where the developer pulls the code, performs code updates with his new logic, pushes the code to the remote SCM or third-party tools. There, an automatic script performs the code validations. If everything is fine and all the tests are passing, we can perform the merge of the code changes. And from this point, we can do more testing. We can do end-to-end testing, negative testing, performance, scalability, and we can do that based on the product that we are testing in different kind of environments, QA environments, dev environments, staging environments, aka non-production environments. So having this continuous delivery pipeline implemented inside our company, it can give us some benefits, right? We can find bugs more quickly in the code. We can do faster application iterations, and more frequent releases will give us reliability on the code. Because we deploy faster, we see that the code is stable. This means that the code is reliable, so we can trust this. But this can be done using this continuous delivery pipeline. But the least, but not the last, we have continuous deployment. So continuous deployment extends somehow the continuous delivery. And here, the difference is that we try to automate the deployment process so that the code can be automatically deployed to production after the entire automated regression testing it's validated and we don't have any critical bugs. So to deploy to production, we can use different strategies like blue-green deployment, canary deployments, rolling updates, depending on our environment. What is blue-green deployment or canary deployments or rolling updates? I used the terminology from the Kubernetes side, but to have one short overview, blue-green deployment, it's basically replicating the production environment and having two production environments, right? You have the current production environment with your application, which is up and running. And you have the blue deployment where you will deploy the new application. And you just switch between them. So now you are using the production, which is the green one, and you just switch to the blue one. If everything it's not okay in the blue environment, you just switch back to the green environment, to the production environment. The downside of this is the fact that you have to create or to replicate the production environment. And from some organizations, this can be expensive. For some organizations, it can be very easier to create. But it depends, it is your choice. Canary deployments, on the other hand, give you the ability to release inside the production environment your new code, your new build, your new version of the application. But that new version is just used by a small amount of people, and it's not available to the entire users or to the entire teams. And after that small amount of people are validating and testing and interacting with this new version and are giving the okay, you can deploy it to a full production deployment by promoting that specific build. And this is done somehow using more automation and without any manual steps involved here. So if you are trying to look at continuous deployment workflow, we can see that we have all the previous steps from the continuous integration and continuous delivery. And what we add here on top of that, on top of pull, code update, push, code validation, merge the changes, and perform the validation test and release, we have deployed to production. And this deploy to production, it's somehow done automatically. So if we are looking at this diagram where we can compare the continuous delivery and the continuous deployment, we can see that at a point in the pipeline, from the acceptance test to deployment to production, we have this manual step, right? This is in the continuous delivery workflow. The difference, it's very straightforward that in the deployment, everything is done in an automatic fashion. How you can do that is by using some kind of flags. And this can be implemented with some feature flags that you have to enable them inside the pipeline, and activating those kind of feature flags, you automate this continuous deployment pipeline. So I think this will conclude the DevOps history and culture. There are many tools that are part of the DevOps ecosystem, and you can see that we have here a periodic table of DevOps tools which are divided in specific areas, right? So we can have tools for cloud, for collaboration, for deployment, for analytics, for security, and so on and so forth. Are too many, we cannot cover all of them, but if you want to learn more about specific tools, don't forget to check out our DevOps learning paths on DevOps Artisan. And as you can see here, we have from the Python, Jenkins, Ansible, Kubernetes, Elastic, to more advanced trainings like Prometheus, implementing security in DevOps, and so on and so forth. So please take a look at the end of the training or when you have time. And if you have questions, of course, don't forget to send emails with questions on askformore@devopsartisan.com. Good. I see that people are still complaining about the audio. I hope now it's better. And don't forget about the questions. I see that are so far, I don't see any question in the chat. Please don't type them in the chat. Please put them in the question and answer section if you have one. So let's move on and discuss a little bit about Jenkins. So the first question that we need to ask ourselves is, what is this tool and how it can help us, right? So you can think that Jenkins, it's just a server which runs on a Linux or Windows environment, which can help you to automate all kinds of tasks which are related to building, packaging, testing, delivering, deploying your software stack, let's say. And this tool can help us from a DevOps perspective, right, to create a continuous integration, continuous delivery, and or continuous deployment, depending on what you are trying to achieve by using this tool. You can compare it. I don't know. I hope everyone is familiar with Linux environments, or everyone used cron jobs also on Windows machines, not only on Linux. So a cron job is something that it's executed at a specific period of time, and it runs what you define to run. So on the same manner, you can think that Jenkins, it's a tool similar to a cron job that will help you to run those repetitive jobs that you will create inside the Jenkins application. So because it's open source, this means that can integrate with different other tools like Git, Maven, with Ansible for continuous configuration, with Puppet, with Chef, with third-party tools for testing like Selenium, Robot Framework. And of course, you can integrate it also with Prometheus or Nagios in order to perform continuous monitoring, of course, of your jobs in this case, if this is the case. Or you can create jobs that will connect to other systems and extract specific metrics from those systems, and using some kind of logic, it will generate a report or something like that. So you can use this tool in many ways. The core of using this tool is that any task which can be automated when specific events occurred can be integrated in Jenkins, right? So think about this. A developer is pushing code to a Git repo, right? So maybe you would like to perform the following. On each commit that is done, I want to execute a specific, to run specific tests. And only after that those tests are passing, we can accept the code, perform an automatic code review, and merge the changes from the feature branch to the master branch, right? This can be an example. Or maybe I want, when a job fails, to send me a notification via email, or maybe on Slack or other third-party tools, right? It depends on the use case. So let's see how we can do that. In Jenkins, we have this concept of jobs, right? So basically a job, it's anything that can be defined as a task that we need to accomplish, right? And because we create it once and we make it work, this means that it will reduce the cost and the risk of mistakes, right? Because it will eliminate that human intervention. We created once the job, we specified and we defined what the job will do, and we don't perform other changes. It's not like running some scripts from the shell, and maybe you added a new line or inserted a new character in a command, and that command will fail. You can do it once and it will work ideally forever, right? Another benefit of using Jenkins and using this concept of jobs, it's the fact that if you want to have specific functionality inside the Jenkins, you can do that. And you can do that using plugins, right? So plugins are a piece of code that can be integrated with the Jenkins core application and extend the functionality of that, right? And using this, will have an easy integration with other applications and services. And because, again, it's open source, you can write your own plugins in your own favorite language in order to make your life a little bit easier by automating yourself out of a job, right? And in the end of the day, from the point of view of DevOps culture, it will increase the productivity by doing that. So, key aspects from the point of view of Jenkins, remember that it's open source platform, which is helping us to implement specific DevOps pipelines. It's cross-platform, so you can deploy it also on Linux or Windows environments. Because it's used by so many people in the community, it's very extensible because there are many plugins available on the market, and you can integrate Jenkins with anything, right? You can integrate it with Docker, with Kubernetes, with cloud vendors like Amazon, Azure, and Google, and so on and so forth. And secondly, it's a reliable solution because it's for many years used in production systems, right? And it's stable and gives you confidence. Of course, this is not the only tool that can do that, but it's the most reliable one, as least of what I know. So, going further, we discussed about the jobs, right? But what is a pipeline, or what we want to achieve using a pipeline? A pipeline, basically, it's a set of a list or a set of steps which are called stages. And in each stage, we have a list of steps, right? So a stage, it's a block that contains a list of steps and can be something that means or it's meaningful to you. And it will give you some kind of visualization from the point of view of the pipeline. Now, let's see and dig deeper, make a zoom in inside the step. The step is basically the task where you specify what you want to execute them. Git clone. This is the step, right? Step 2, remove /root. I don't know if you have sudo privileges. Delete all the Ansible jobs, and so on and so forth. And chaining these stages together from stage 1 to stage n, we create the pipeline, right? So we can say that a pipeline, it's a series of stages which includes a series of steps. So are all the tasks that we want to execute in order to automate our workflow from the Git commit to deploy to production, right? So stage 1 can be committing the codes, downloading the code, compiling the code, performing some unit tests. Stage 2 can be more testing, right? Performance testing, load testing, negative testing, more functional testing, end-to-end testing. If everything is fine in stage 2, you can create stage 3, right? Deploy to production. And here you can, or non-production, let's say. Maybe you have to create the environment, right? So you can use some Terraform scripts in these steps. And after you create the infrastructure and the environment, you have to use some Ansible scripts in order to perform some specific configurations, right? Install maybe a web server, an Nginx, an Apache, and so on and so forth. Maybe you have to configure some firewall rules, right? Maybe you need to enable SSH for specific users in order to copy the artifacts. This can be another step, right? And so on and so forth. And chaining all these tasks from the building the application to deploying to a non-production environment or production environments, it creates our pipeline, an end-to-end pipeline. So what we can see here, it's the fact that using Jenkins, we can use and integrate with different kind of tools and chain those tools in such a way in order to create an end-to-end continuous integration, continuous delivery, or deployment process. So another visualization of this continuous integration, continuous delivery pipeline is the following. So we start with version control in the left. We perform our building of the binary or the Docker image and so on and so forth. We're doing some unit tests. If everything it's fine, we're going to deployment. If the deployment runs without any failures and the production feedback loop gives us no errors, we can perform more testing, and going further into the chain, we hit deploy to production, right? And don't forget that we have to monitor the entire infrastructure from the version control to deploying to production in order to be sure that nothing have changed while modifying the code. And all this fast fail information is, if it's the case, is gave to us using these production feedback loops, right? Because all of us like feedback, right? And we want feedback fast in order to improve or to fix the problems that we created intentionally or unintentionally. So measuring and validating those measurements, it's another core principle in the DevOps workflow. But again, this is maybe for a new webinar, which can come later in next month if you want to learn more about monitoring. Okay, so going to back to our continuous integration and continuous delivery pipeline, we have the version control, right? And here we have all the means to organize the files, coordinate the creation, update, delete, and this has to be done across the teams and even if on organization side, right? And here we can use different tools like Git, Mercurial, Subversion. And of course, we can integrate these and use these tools inside Jenkins. Going further, after we have all the code in the SEM, we have to compile that code, right? And here we have the build step. And here, all the features of the code from different feature branches will be merged. And if it's the case, we will use a compiler in order to create the binaries, or if it's not the case, like C, C++ languages or Java, we can use other tools that will build our application. Maybe it's Python, and so on and so forth. Unit testings, right? Here, after we created our application, maybe we can perform some basic sanity tests. Maybe we have to install this binary somewhere and validate that the installation was successful, or perform some unit tests or perform some functional tests. It depends, again, based on what we try to accomplish. Oh, and of course, the most simple one is to validate the functionality of the code and to validate that the code didn't break by performing those merge changes and so on and so forth. If something goes wrong, we have the feedback loop, we have a notification, we see that the build failed, we have to investigate, troubleshoot, fix the problem, and start over from the version control, right? Because we have to, in order to fix the problem, we have to make the change inside the version control, we have to commit it, and again, go to the entire process, right? But let's assume that for now, it will pass. And we go to the deployment. So in the deploy phase, we try to replicate and put the application or what we are trying to build into a test environment or staging environment or dev environment in order to perform more testing on it. And here again, we can extend our testing, non-functional, functional, user acceptance testing. It depends. It can be updated based on your needs. If everything is fine, we can perform more testing. Maybe if we have a blue-green deployment, we can validate and perform some user acceptance testing in the blue environment where no customer will be affected, right? And if it passes the blue environment, this means that we are ready to deploy it to the production environment, right? And we have to reiterate over and over again from the beginning. Maybe you have to start a new feature from the customers, we have to implement it. And again, we are going to hit and interact with each step from the continuous integration and continuous delivery pipeline. Going further, so far we discussed about building security, about continuous integration and continuous delivery. But let's see how we can add also security on top of this DevOps process, right? Because what we discussed here didn't mention anything about the security of our applications or our products. So we don't want to perform our security validations performing some manual steps, which we want, or at least we want to achieve this kind of automation also from the point of view of security. I know that security, it's not always so easy to fit in DevOps continuous integration, continuous delivery workflow, but let's see how we can do it at least, or how we can try from the point of view of a high-level discussion. So what we are trying to do here is try to see how we can remove manual interaction and try to automate more of these tasks. We can think from another point of view of the following. If we do it once, a specific task in a manual way, and we see that we have to execute that specific task each day, and if we see that we can automate that specific task, this means that we should focus on automating that specific task and removing toil. So what is toil, you will ask, right? So toil it's something that it's repetitive, it's a manual process, can be automated, and it's not automated. And doing this, removing toil from your bag, let's say, of tasks, it will give you the ability to focus more on innovation or deploying new scripts or creating new pipelines or focusing on what it is important, right? Of course, are scenarios that cannot eliminate 100% this toil, because some things from the point of view of the automation can introduce more complexity than it needs and create more problems, right? And in this kind of case, maybe it's not the use case to try to automate this process. So to be more secure, at least from the point of view of a CE, continuous integration, continuous delivery pipeline, we need to insert security also in the pipeline. So how we can do that? We have to put security from left from the development phase, right? And having security from the development phase, we can be more effective, and it will give more confidence also in the entire continuous integration and continuous delivery pipeline. So how we can do that? Think about this. We can add security on the SEM, on the developers tools, on the build phase. Also security from the point of view of a continuous integration, continuous delivery pipeline. Going to specific environments, we can put security in the staging environment and also on the production, and so on and so forth. Of course, each phase can contain or can help you implement security at different levels. From the point of view of a developer, you can use some specific tools that will let you know if the code it is written in a good manner and you don't have any, I don't know, maybe buffer overflows, and it performs some static analysis on your code, right? From the point of view of the code repository, think about of the following, right? Maybe you have to automate some processes, and those processes maybe require some credentials, maybe some SSH keys or tokens or other kind of sensitive data, right? And guess what? Developers, what they do, they commit these things inside a repo. They don't care if it they committed on private key inside the GitHub repo. I saw in the past, I saw some repos that had private keys from AWS, and you took that key, and of course, beside that private key, there was also a TXT file and gave you the public IP addresses of those machines. And guess what you can do? Download that key and connect to that machine. And voila, you have a breach in your environment. So there are tools that can help you preventing committing, in this case, sensitive data inside the repo, right? So they will abort your commit. That will happen. You can create some predefined rules with some specific patterns, and they will, when you try to commit the code, they will validate against those rules. And if you broke the rule, the commit will be aborted. And so on and so forth. At each layer in the continuous integration and continuous delivery, you can add you can add some kind of mechanism of security. Of course, we cannot cover all of them, but if you want to learn more or what you can use, please feel free to join DevSecOps trainings, which are focused on security on Docker and Kubernetes. And there you will find more information about security inside DevOps environments, let's say. What we are going to discuss, at least in this demo, and what I'm going to show you, it's how we can perform or extract or find vulnerabilities inside our application, right? So in this case, we will assume that we have the application packaged in a Docker container. Maybe that application has some vulnerabilities inside it from the point of view of the libraries, the binaries used. And what we try to accomplish, we have the code, we have to build the image, we have to scan the image, and if the scan passes, we push the image to Docker Hub, let's say. If we find vulnerabilities, we will fail the build and we will not move on. We are not going to do the entire end-to-end continuous integration, continuous delivery pipeline. We are going to do just a small part. So we can think of the following: downloading the code from the SCM, building the container image, scanning that image, publish the results, and based on the pass or fail criteria, push it to a Docker registry. In this case, will be Docker Hub, right? So let's take a look and see what we can do here. So what you will need if you want at least to deploy or use or create this kind of pipeline, you will need, of course, the following: a Jenkins server up and running. You will need an application, of course. In my case, it's somewhere on GitHub. You will need also Anchor. Anchor, it's another tool, and the purpose of this tool, it's to find vulnerabilities inside of our applications, which are packaged as Docker containers. And of course, you will need an account on GitHub. I already have it here. So the pipeline, it's already created and contains the following, let's say, stages. We have the cloning of the code. We have building the image. Okay, we perform the container security scan. We deploy the image to Docker Hub, and we have a cleanup phase. So we have 1, 2, 3, 4, 5. 5 stages. Of course, in each stage, we have a series of steps, more or less. So how this can be done, as you can see here, my job is created as a pipeline script. And if you are looking at this, basically this is some kind of code, right? So what we can do more on top of this, we can try to automate also the automation of the Jenkins jobs. Because if we want to add more steps, we can put this in a GitHub repo, and we can create new stages or new steps. And on the commit, you can create a new build, which will run this pipeline, and things can move on in order to create that end-to-end workflow. So let's take a high-level overview of this. As you can see here, I have defined a pipeline with some specific variables which are related to this pipeline. We have a registry. Like I said, this is the Docker registry. In my case, it's on my account under Enter. And as you can see, I have images here. Docker image is none, agent any. This means that this pipeline can be deployed on any agent. In this case, I don't have any agent. So an agent can be a virtual machine which has, or a Docker container, or a Kubernetes pod, or something else. But the requirement is to have a Jenkins agent which is running on top of it. Why is that? Maybe you have specific applications that need specific environments, right? And those specific environments, maybe you want to use and integrate them in this continuous delivery and continuous integration workflow. So if you have this kind of requirement, you have to just specify here agent and you specify the name, right? So let's see what is the first stage, right? It's cloning from Git. So as you can see here, we are using another tool, Git, which also has to be installed on the Jenkins machine. And here it's downloading our code, right? So if I'm going to this location, as you can see, I have a Docker ignore and a Docker file. And this Docker file contains these different steps and contains another image. And this image has some vulnerabilities inside it, right? And we want to find these vulnerabilities and try to fix them and run again the scan and try to improve that. This is the main idea, right? So we download our code from the Git. And the first step, remember, I have a Docker file. For those who are familiar with Docker file, the first thing that we need to do is to create the Docker image, right? Because containers, the application will be created from that container image. Remember, containers are ephemeral. So the next step after we clone from the SCM, it's to create this image, right? And here we are using some specific commands and we are performing a Docker build using some specific flags. In this case, it's build number. After that, we are going on the next stage and we are performing the security scan, right? So here, for this step, I have the Enter plugin, which is integrated with Jenkins. And basically, this line, Enter, and so on and so forth with these parameters will perform the scan. I will put this to false because I want the build to be successful. If it's true, it will fail. And let's say we execute this Enter part. So we perform the scanning with this tool. This tool, by the way, it's also deployed in a Docker environment. So it will scan the image on a Docker environment and it will find vulnerabilities. It will report those vulnerabilities. And based on the report, it will move to the next step or not. And in this case, the next stage will be deploying the image to the Docker Hub. As you can see here, we have Docker image push. And lastly, we can have some kind of cleanup with specific shell scripts. So this is the pipeline. Let's apply this and let's see if we can run it. So the last build 19 was failed. As you can see, it failed the security scan. Let's do build now and see what happens behind the scenes. Remember that view discussion for the steps, for the stages. As you can see, these are the stages, the name of the stages for visual representation. It will help us to see more clearly what is going on inside our CI/CD pipeline. So if I'm clicking on this console, I will see that the code is downloaded from Git. We're performing the Docker build. As you can see, we have different Docker outputs here with all the steps from the Docker file. After that, we started the Enter. And if you are taking a look at this, we can see that a worker took this job and started the scanning process, right? And going further, we can see this request was accepted and we are waiting for specific outputs. And as you can see, this is an automatic loop, which is telling us that the image it's analyzing and we are waiting. It will take another 1 or 2 minutes. Now it's in analyzing state. And at the end of the scanning, because I enabled that variable failed on ban, it will move to the next stage, even if it will find vulnerabilities. And it will do this, in this case, for 5,000 retries. And the retry, it's done at 1 second interval. Good. Let's wait a little bit more for that and see how it goes. Meanwhile, please feel free to ask questions because we are reaching the end of the webinar and I will be glad to respond to your questions. Okay, so the scanning was completed. Now it's logging to my Docker Hub account and is pushing the image to that account, right? And all of these steps are done inside the pipeline. So if I'm going to my Docker Hub account and perform a refresh here, I should see my build. I think the number it's 20. So it should be 20 here with tag 20, right? Okay. Let's see all of them. And I consent the cookies to latest. Okay, as you can see, look, 20 a minute ago, right? So it was pushed from my Jenkins job. And as you can see, the pipeline ended with success. And it's green. You see, each stage of the pipeline was success. So you will ask me, what is the difference between build 20 and build 19? As you can see, in this case, it was failed. Why? Because I told I configured the Jenkins pipeline to fail the build if Anchor will find any vulnerabilities inside of the Docker container. So let's look and see what vulnerabilities we have here. So we have this Anchor report. And as you can see on the latest image of Anchor, we have different common vulnerabilities and with different problems on the OS package, on DPD, on the DPKG, high vulnerability on the Ubuntu, and so on and so forth. So we have many. And here we have the gate action stop. Basically, if we the Anchor engine is configured to fail the build if it founds high severity CSVs, right? I know this is a demo environment and it's an old application with some old CSVs, but if you have code that uses a lot of libraries or modules, and those modules change often because you are performing different updates and so on and so forth, you will need some kind of analysis engine in order to validate your Docker images, right? Of course, if you have sensitive and important data here. And as you can see, we have many CSV found in this. So basically, this should fail. This should not be deployed to production. So I see a question here, at least two questions. So I see a question. Is there a way to build image and destroy the image through Jenkins? I hope you are referring to Docker images, right? If you are referring to Docker images, you can do something like this. I think I already have in this pipeline in the cleanup section. So in the cleanup section, you can do something like this: Docker remove image and the name of the image, right? It's run inside the shell script. And I see another question from Daniel. And the question is the following: if we don't push sensitive data in Git, how we can replace during building and deployment? So for Daniel, also in this pipeline, I have some sensitive data. And in this case, the sensitive data, it's stored, are my credentials from, I think, GitHub. I have the Docker login, right? So Jenkins gives you the ability to create some variables, some secrets inside Jenkins where you can store your user and password. So here in Jenkins, there is a section. Let me see where it's. I'm logged in. One sec. Manage. You have global security, and here you have manage credentials. So you can create different kind of credentials, and as you can see here, I have an credential created with the name Docker login, and here are my credentials related to the account and the Docker account, right? So you can create different kind of credentials here: username, with password or a GitHub app, or you can create inside Jenkins a secret for a private key or a secret file or a certificate, and so on and so forth. And this will be stored in a secure way inside Jenkins. I hope it answered your question, Daniel. But I mean, Daniel is asking, but I mean, for example, user password of database or other things. You have the option again to create it inside Jenkins, or if you are using microservices and you are using Kubernetes, you can use some config maps, and you can use secrets from the Kubernetes world, which are another topic. So this can help you to inject configuration data inside your application. If you want to put this inside SCM, you have somehow you cannot do that. Let's say you have security in place. You have to use a third-party tool like Vault from HashiCorp, from where you can extract that specific credentials or the credentials that you need. And of course, with Jenkins, you can integrate with third-party providers and with third-party tools like Vault. Basically, Vault, it's a tool for managing sensitive data. This is the main focus of this tool, storing secrets, credentials, passwords, and it gives you the ability to interact using REST API or UI interface or command line and extract sensitive data in order to be used on another application, a database or something else. I think that's it. This is the end of our webinar. So don't forget, you will receive email with a discount of 25% if you want to join new trainings. The presentation and the video will come after the webinar. And I see another question from Daniel, and the question is, how can we start integrate a Jenkins file from an MS? What is an MS? Microsoft server, if I'm microservice. So if you have the Docker file, because the Docker file, it's your application, and the microservice is created using that Docker file, this means that that Docker file is somewhere in a Git repo, right? This means that we can download the code from Git. We have to build the microservice using Docker and move on into the pipeline in order to create our end-to-end continuous integration, continuous delivery workflow. We have in each microservice a Jenkins file. So you can create different jobs for each microservice if each microservice has its own Jenkins file. And you can create some interactions between those jobs. Maybe you want to execute Jenkins file number 1 from microservice 1, and only if Jenkins file from microservice 1 it's built with success, maybe you want to trigger a new job that will execute a new job which is calling Jenkins file from the microservice number 2, and so on and so forth. Let's conclude this webinar. Thank you very much for joining. I hope you enjoyed, and see you on the next one, which is related to site reliability engineering. Thank you and have a nice day. See you next month.